Hello everyone, welcome to the channel. And today we're gonna solve the question, a part B, Pathless of a Codeforces Round 1040. And I know I'm too late for this, but don't worry, let's try this. And so first of all, we see the question, that what question says, and then we analyze that what the input and output are concluded, and what question want to say us. Okay, let me check. Okay, my face of camera. Okay, now it's good. Yes, it's good. Okay, so here we see there's a array a1 a2 consisting of a 0 1 2 and the integer s. It's guaranteed that contains at least 1 0 1 1 and 1 2. So basically, this is a game between the Alice and the Bob. So Alice want to start from the index 1 and perform step of a length 1 to right or to the left. Means she can move either to right or the left in the array. And the each position she moves is equals to the s. Let's suppose she moves 2 positions, so the sum equals to s, like this. While Alice moves, she calculates the sum of the value she is visiting, and she wants the sum to be exactly s. Okay, so now here we see Bob wants to rearrange to prevent Alice from achieving her target, determining whether it's possible to rearrange such that Alice cannot find her target sequence. So Bob, play a villain role in this game. Just want to disturb the Alice so that she can't move to the each position, and her sum are not equal to s. Basically, this is the main concept. So here we see the input. This is the basically a test cases, 6 test cases, and the first line each contain 2 integer and an s. S is basically a sum, and then basically the numbers in the second line. So 3 2 0 1 2, as we see in output 0 1 2. How it's possible? We can see I have a notion notes for you to explain you conceptually in a better way. Here we see in the first test case, an rearrangement of a can prevent Alice from achieving her target. So the sum is equals to 2. So 0 1 and 2. It's possible. See how it's possible. Okay, so now I can show you my notion notes for this question especially. So the main story is Alice versus Bob. What does Alice want? Alice has an array that contains only the value 0 1 2. Her goal is this: Alice start at index 1 and must index at in n. At every step she moves either left or the right by 1 index, and she wants the sum of all values visiting during a path to be exactly s. In short, it's a start position 1 and position n. Each moves of the step is like plus and minus 1. Means she can move either in the right or either on the left. So like this, 1 2 3, or in the array 1 2 3, she can move like 1 2 3 and 1 2 1 2 3, like this. The sum of all values visited is equals to s. And what does Bob wants? Bob has a special power. He can rearrange the array before Alice start. Like his goal is to rearrange the array like this, such that no matter how Alice moves, she can never reach from the index 1 to n with the sum of visited value is equals to s. In short, we can say that Alice may try any left-right path, but Bob wants to make sure no such path even add up to s. Game rule is this: you can pause the screen and read this in a careful manner. After that, this is the code is smartly checking if the total sum is already more than the target. See the concept. If the total sum is already more than the target, only one more than target, then the Bob can ruin, Bob easily won. Else, Alice will always be smartly enough to build some walking path to reach the target, which is basically, a second number in the test cases. Key observation is this: thus Alice can move back and forth in the array one step at a time. So even if we can rearrange, arrange it smartly, she can go over the same element multiple times. If we see target sum is equals to total sum, Alice can revisit some element. And if we say target sum is minus current sum is less than 0, and is difference, we calculate difference in the code. Wait, different equals to 1, or difference is a less than 0, then the Bob has a way to stop Alice. Okay, if the difference is more than 1, then we can't do anything. Alice is already won the game. And Bob wants to rearrange array in such a way that Alice can never reach the index 1 to n with the sum s. This is the last line. So here's the code in front of you. We define some macros for the cleaning code and some functions to input to fast input output operations. And here we input the test cases and name a variable sum equals to 0, zeros equals to 0, and ones and twos. Okay, after we can input all the element which is in the array, like for int I equals to 0 up to in and I plus plus, and we can see in all the element and checking if the element is equals to 0, then we can add 0, and if 1, then we can add ones, and if 2, then we can add 2. We can do this in difference equals to s minus sum. So s is basically the target and sum is basically when you add each element in the input, like 0 1 2, and when you add 0 1 2, so it is equals to 3. So you do in the first test case, we see that the target I think is 2, so 2 minus 3 is equals to minus 1. So yes, it is a case where you apply this because it is a a less than minus 1. Then we can rearrange to stop Alice. See what I do. I can make a vector, vector name result and output in a tricky order to block Alice path. We can check if I equals to 0 up to 0 and I plus plus, then we can push back each element of a 0 to 1 in the result vector. After that we can do this. I hope you understand why I can do this. If you can't understand, please comment out. And else we can do minus 1 if is equals to 1, is greater than 1, means your target is difference is greater than 1. After all that, this is a input output operation for the fast allocation of the compiler, and we can int t, c int t, and while t minus minus we can call the compute function for the better code. And for if you understand, I hope you understand why I can use this, and the last statement I can return. Okay, so let's do a detailed rerun of this code for your understanding. Okay, so here let's do a detailed try run. Here we see n equals to 3, s equals to 2, array equals to 0 1 2. Okay, so step by step we can do this. N equals to 3, s equals to 2, here 0 1 2, y. See, these are the four sum, zeros, 1 2 are the four variable in the starting. They both are all are equals to 0, and when we iterate a loop to calculate the sum and the counts, so for I equals to 0 to 2, okay, so 2 is the target. Basically we can sum up all the input in the sum variable and update the counts. Say if I equals to 0, a equals to 0, means sum equals to 0 and 0 is equal to 1, because in the zeros name variable we can add 1. Okay, we can write the code in which we see that zeros plus plus, after we can iterate each element of the input, and when I equals to 1 we can add the 1 and as the same in the 2 case. Okay, if the sum out is equals to 3, in the first test case 0 1 2, so sum equals to 3 and we all have 0 1 2 is equals to 1. Okay, if we calculate the difference we see minus 1, and now we check the condition if difference is less than 0 or difference is equals to 1. So yes, our difference is less than 0, so we difference is equals to minus 1 is true. We can rearrange to block Alice path. Now we build a rearranged result. For 0 we can push back 0 in the code and all that. The final input we can see the 0 to 1, because we write in this way now. For zeros we can push zeros, and for 2 we can push 2. That's all. And the last stage of this code, we can the Bob can rearrange 0 1 2 to 0 2 1, so that Alice can't find any path from index 1 to index n whose visited sum is equals to 2, because at 0 1 2 she moves 3 steps, so it's equals to also 3, like 0 plus 1 plus 2 is equals to 3. So the game is won by Alice. But how can Bob won this game? Bob basically have to rearrange the element. In this case 0 to 1, so 0 plus 2 plus 1, at the 1 stage she can add up 2. That's why sum is not equals to 3. And try every path Alice could take from index 1 to 3. Array is 0 to 1 and the path 1 to 3, so it means 0 2 plus So as in the same, I can explain you in the previous, a minute. uh, the same line, path 1 to 1 2 3 is equals to 5, try anything, can't make some, equals to 2. So in the second number, which is equals to target, so we have to break the target. So Alice can never reach to the target after iterating each element in the array. So Bob can successfully block Alice. And if he can't block the Alice, then we can print -1. Okay, this is the concept. And if we try another test case, sum equals to 3 in this test case, so difference is equals to 0. How? Because 0 plus 1 plus 2 equals to 3, and 3 minus 3 is equals to 0. Difference. Okay, so we can put -1. Rearrangement is not possible. Alice can reach element. How? Because if you iterate 2 in this place, in the place of 1, so 0 plus 2 plus 1 is equals to 3, and 0 plus 1 plus 2 is also equals to 3. So there is no chance to rearrange the elements, and here Alice can easily win. So I hope you understand this question, pathless. Okay, hope we meet in the next video. Until